or continue our study of numerical integration, and now we're going to look quickly at the trapezoidal rule. So the idea of this is going to be the following. So you're going to have your favorite function that you're going to be computing your area underneath. So from A to B, wherever they are, you're going to subdivide it. I guess this time I can do about 6 of them. It really doesn't matter. And recall what we've been doing. So we have done before, at the very beginning, we did right endpoints. Then we also did left endpoints. Then after that, we did midpoints. And well, the next idea then is make trapezoids. So you're gonna grab both heights at the ends here and here, and you're gonna draw a straight line between them. So from here to here, straight line, sort of here to here, straight line. And that you can see is going to give you a better approximation than a rectangle. Not exact, but much better. And that's the idea of the trapezoidal rule. So you're going to be putting trapezoids. So quickly, if you have a trapezoid of this form with height 1 and height 2, and a base that conspicuously was going to be called delta x, we have that the area of that trapezoid is going to be 1/2 of the sum of the heights, so the average of the heights, or arithmetic mean, I suppose, times delta x. So base times the average of the heights. So that would give you right there your area of the trapezoid. Now, what you could do then, you would have to say that you're going to start with the trapezoidal rule. Let's call it T sub n. If you start writing it out, you'd have the area of this first guy would be delta x. I'm going to make a common factor with that one. So you would have, let's call it x naught plus x1 over 2. And I suppose I didn't need x naught, but I needed f of x naught because I need the heights, and f of x1. So let's rewrite that. We don't need the x's, we need the f of the x's. But then for the next one, I'm going to have x1 here, x2. So I'm going to have f of x1 plus f of x2 over 2. And you'll continue like that until you get to the last one. This is going to be xn minus 1, and this is going to be xn. In our cases, n was how many did I say? 6? Something like that. In any case, you're going to have f of x of n minus 1 plus f of x of n, x of n, all over 2. And that could be your formula. However, you can still divide this by 2 and get the sum of, you see, f of x naught plus, then you have f of x1, and f of x1 appears twice. F of x2 would appear again twice. F of x2, not f of 2. And you continue like that until you get to f of x n minus 1. But you gotta be careful because f of x of n doesn't appear twice, only appears once. And that right there gives you your formula. But now, you can also rewrite this, and you can add f of x naught plus f of x1 all the way out to f of x n minus 1 first, and then you're just separating them out, and then f of x starting at f of x1 plus f of x n minus 1 plus f of x n. So basically just noticing that this guy appears only once, so you put the rest of the terms that appear twice, you just grab one of each one of those that appear twice and give it to this guy. Now for the other, you grab the guy that only appears once, and you give the rest that appear twice, you grab one of each and give it to this guy. But why is that even interesting? No, it's not interesting at all. No, it is. The reason why is because if you multiply the delta x across, this right here in red times delta x is just the left sum L sub n, if you will. And this one right here, when you multiply times delta x, is the right sum R sub n. And this over 2 that was left over here. So the trapezoidal rule is not that fancy. You are putting trapezoids underneath, but really it's just the average between the left and the right sums. And some of you did that already on your homework. All right, so I think I'm gonna go ahead and create a video how to do this, how to implement it in Excel. And then we will wrap this video up. So this is going to be a short one, and then I'm going to do one on its own for Simpson's rule. So, all right, so let's do that. I'm going to jump to the Excel, even though when I record the videos on the computer with Excel, sounds like I'm underwater. Anyways, let's do that.
All right, so we're gonna do now the trapezoidal rule. I'm still gonna use the same 8 trapezoids instead of 8 rectangles. So the way you would do it, the first part is gonna be the same. So you're gonna have your x's, and you're gonna start with the numbers just as we did before, 0, and you're gonna go ahead and for each row, you're going to be adding a delta x to move further. So you're going to put $sign so that doesn't get changed. So you're always adding the delta x until you get to 1. So this time I have from 0 to 1. That's my delta x. Now, in this one, what you can do is you can evaluate f of x directly. So we're just going to evaluate f of x, the function being 1 minus x squared, just easy function. 1 minus, but in place of x, I put the x cell, or in this case F5, I just click on it. I'm going to square it, and right there it gives me the evaluation. So I just grab that square and just drag down, and it gives me my values right there. Now, what you're going to do, or what you can do, is do your, or compute your Rn and your Ln. So the right, that's right here, Rn, so the right sum, in this case R8, because we have 8 rectangles. So when you start summing on the right, you grab the values of the function starting at 0.125. So you're going to sum this first values here. And that is not going to be R8, that's just the first sum. In addition to that, you have to multiply times your delta x. And that is going to give you your right sum. You see how the right sum is so much further away? Remember from the previous video, the exact value of the integral we're looking for is 2/3, which is 0.66 periodic. The right sum is really far. Now, if you want to do the left sum, then you're going to be grabbing the first, so sum of the first 8 endpoints, or the height of the first endpoints, and you're going to multiply times your delta x. So that gives you 1. So you see you're overshooting quite a bit and you're undercounting here by quite a bit. But the trapezoidal rule will then give you a approximation by doing the average between them. So you do this plus this divided by 2. That's your trapezoidal rule right there. And it's 0.64. It's not nearly as good as the midpoint here. Your error, we can compute the error, is going to be here equal to 2/3 minus 2/3 is the exact value of that integral, because we can actually compute with the fundamental theorem of calculus. So the error is approximately 0.0013. The error here for this one, for the trapezoidal rule, is going to be equal to the 2/3 minus this one. So you see it's a little bit larger, but I feel like those are pretty good. You'll see that Simpson is extremely accurate. Excuse me, but we're gonna do that in the next video. I think that otherwise the video will get too long. So let's keep this table going, and in the next video I'm gonna do Simpson. So let's merge this and call this trapezoidal, so you can download it from our Canvas page. All right, so that's that for this video. So see you in the next one. Thank you for watching.